Hi, sending Christmas greetings to all of you. This video is a special video. It is mainly on understanding behavior of a sequence. It assumes well-known facts like coprimality and fundamental theorem of arithmetic, geometric series, and idea regarding denumerable sets and divergence of the series 1 by n. A problem will be half solved in the video because we still don't have some machinery for the rest of the solution. What are you thinking about? Our assignment. It asks to write about the behavior of the sequence phi n by n, but it seems confusing. The sequence is neither increasing nor decreasing. It is awkward. Okay, let me help you. If the sequence is problematic, work with the subsequences. That shows you the behavior of the sequence. You know subsequence? It is just a restriction of a sequence to an infinite set. I am trying to. Okay, is your definition clear? Yes, phi is an arithmetic function, and at 1 we make it 1, and at rest of the n, which is a natural number except 1, we make it the cardinality of the set of all natural numbers less than n and prime to n. Fine, now what is your guess? See, I just see that phi takes high values at primes. Wow, you are on a good track. Can you give me a formula for phi? Yes, but I think you did that in class. It's long, I forget. It's just a use of the fact that phi is multiplicative. You just need to understand phi of b to the power k. Oh, I understand that. It's p to the power k into 1 minus 1 over p. Yeah, now multiplying for these p to the power i's, you'll get the whole formula. Okay, now if I put n is equal to p to the power k and vary the power, I get a result independent of k. I get phi n over n is p minus 1 over p. That's so interesting. So, what do you think about the behavior of the sequence? It is having at least a denumerable set of subsequential limits, as primes are denumerable. Good. Now half of the work is done. Now tell me, what else do you have to check? I have to check what are the other subsequential limits. I need all of them. I also need to see if there is any subsequence which is divergent. Can it happen? Diverging subsequence? Phi n over n is bounded. By what? By 0 and 1. Because 1 is always prime to n and there are n minus 1 naturals before n, isn't it? Of course. Now your divergent subsequence is gone. And it remains... From the formula, it is also clear that we can combine primes and get differential subsequential limits. Now these limits are all between 0 and 1. I'm interested to know if 0 and 1 could be limit points of the sequence. You said something in the starting of the discussion. Let's see. What is phi 2 over 2? Half. Phi 3 over 3? 2 over 3. Then at 5, 7? 4 over 5? 6 over 7? They go close to 1 as the argument increases. Wait! P minus 1 over p is going to 1 as p varies to infinity because primes are unbounded above. So 0 is left for your investigation. And if there is any other limit point, you think about it. I am coming. Okay. Did you get something? the terms of the sequence 2, product of 2 and 3, product of 2, 3, 5, that is product of the first k primes, if we consider them in the argument, do we get somewhere? First tell me, why do you think that subsequence converges? This is decreasing and we know that it is bounded, so it is convergent. So you know this theorem, okay? Now it is not at all obvious why the limit of the subsequence is 0. You can use the fundamental theorem of arithmetic and geometric series. It seems hard. I gave you the hints. Use geometric series and fundamental theorem and the divergence of the series 1 by n, and you are done. Okay, I can see the steps. I will start from the limit of product of pi over pi minus 1, and the rest of the steps follow. In this part, you have to be mindful not to write 0 over a number. Be careful. Sure. Oh, now last part left. But I have already got that the sequence has at least countable subsequential limits and that it is finitely oscillatory because it is bounded. But for the possibility of other subsequential limit, I think it needs some concepts that you would not get from sequence only and not from the basic part of series. You need a hard part of series for that. I think your teacher would do that after he teaches you series. But I'm thinking on that. Great, now time for snacks, come on. They have settled for now. The left part of the sum is not doable for them with the present machinery. So you may try it for now. We will get back to you once we do series. Thank you for watching. Thank you for your time.